So I'm going to do just a couple more examples. And what I'm going to do this time is the region bounded by y equals x squared and y equals 4 in the first quadrant. And the reason I'm going to do this one a little bit differently is because I'm still going to do one around the x-axis, which will be fine and dandy. The one that I wanted to really focus on was when I revolve it around something that's not an axis. In this case, y equals 4. And I'm going to show you that in a minute. Now, one of the things I did want to also make sure I got across to you guys while I was doing this video, especially this one in particular, was that when we did an example where we revolved it around the x-axis before, we used the disk method. When we revolved it around the y-axis, we used the washer method. Now, that's not always going to be the case. Sometimes when you use the y-axis as the axis of revolution, you're going to use the disk method. When you revolve around the x-axis, sometimes you use the washer method. Both of those methods can apply anytime. It just really depends more on what values you're going to use. Now, here's what we're going to do again. I'm still going to graph this first. Make sure, again, we're just talking about the first quadrant. And I'm going to go ahead and graph y equals x squared. So, again, you plug in 0, you get 0. You plug in 1, you get 1. You plug in 2, you get 4. And if you wanted to keep going, you could. I'm not really going to worry about it too much because the reason in this case is my other line, y equals 4, is going to prevent me from really going up any higher. So y equals 4 is just this straight line. And it looks like my red marker is kind of going out on me here. Let me grab this purple one. Y equals 4 is just this horizontal line right here, okay? So that's y equals 4, and this is y equals x squared. Now, notice we're using the x-axis first, so the thing that I want to point out to you is we are going to use x's. So we're going to go from 0 to 2 where they cross, okay? The other thing I want to make sure, again, is we're looking at just this region in the first quadrant, which is this, okay? Now, if I'm revolving this around the x-axis, what's going to happen is I'm going to have a curve that looks very similar to this. It's going to come down like this, and it's going to kind of stop here at 4, or excuse me, negative 4. And so that's going to be what I'm looking at here is almost like a reverse bowl. So if I were to take a slice of this, what's going to happen is I'm going to have this big hole right here in the middle, and I'm going to have all this stuff. So this is actually going to be a washer method question. So let me repeat that one more time. We have a hole right here that kind of gets wider and wider and wider as we go until we get to this spot at x equals 2. Okay? Not a very big hole, especially right here at 0 where they actually intersect. So I'm going to go ahead, like I said, and get working on this. Again, I'm revolving around the x-axis, so in this case we're going to use the washer method. So my outer radius when I'm doing this, based off of the x values, is actually going to be this 4, because that's the farthest away it is. The inner radius is actually going to be this x squared. And I know it's kind of weird to say that the x value is actually going to be a 4 and not an x, but that's what it is in this case because it's y equals 4. There's just no x's with it. So let me repeat again. We're going to integrate from 0 to 2 because we're starting at the origin and we're going to x is 2. The y value, or excuse me, in terms of x, we're going to start off with the radius of 4, and I'm going to square it. Can't forget my pi out front. Minus my inner radius, which is that x squared. But I'm going to have to square it too, okay? So hopefully you guys remember, again, for the washer method, we're doing pi times the big radius squared minus the little radius squared again. So big radius was the 4, that's the farthest away one, and the inner one was the x squared, so we're doing x squared squared. 4 squared is going to be 16. So we got pi times 16, and x squared squared makes x to the 4th. I am going to go ahead and pull the pi out just to make my life easy. 0 to 2 of 16 minus x to the 4th dx. I'm going to go ahead and integrate, and I'm going to do pi times 16x minus, that's going to become x to the 5th. So we're going to do 1 over 5, and we're going to integrate or evaluate that from 0 to 2. Again, I'm not going to worry so much about plugging in the 0 as much as I am going to worry about plugging in the 2. If I plug in 0, that's just going to be 0 minus 0, which is 0. So we're going to do pi times 16 times 2 minus 1/5 times 2 to the 5th. All right, 16 times 2, I know off the top of my head, that is 32 minus 1/5 of 2 to the 5th. 2 squared is 4, so 2 to the 4th is 16. So that's going to be 32. So it's actually going to be 32 over 5. So I'm going to just grab my calculator just to be sure. So 32 minus 32 over 5 is going to leave me with 128 over 5. Whoa, I wrote that poorly. 128 over 5, and I can't forget my pi. So that's going to be the volume if I rotate it around the x-axis, okay? Now, I'm going to just point out that this is going to be a little bit different when I revolve it around y equals 4. So instead of it revolving down here, what's going to end up happening is I'm going to use this line, y equals 4, as my revolution. And what's going to happen is, I'm going to use that green again, it's actually going to kind of curve back and end up here at y equals 8, okay? So in this case, this is more of, I guess I'll call it a frisbee. It's going to be one solid piece that just kind of curves back upon itself. I guess a frisbee is not going to be the best explanation of it. Maybe more of a cone almost, but not pointy cone, one of those rounded cones. So like I said, we're going to go from this part from 0 to 4. What I need to worry about right now, though, is I need to make sure I pay attention to the fact that in this case, this is the disk method, because if I were to at some point slice this here, it's going to be solid all the way across. There's no hole right here in the middle. So right now, what I need to worry about essentially is, again, I'm still going to use x values even though I'm rotating it around y equals 4. And you're probably going to ask me a little bit real quickly of why am I doing that? It says revolve it around y equals 4. Well, here's the thing. Y equals 4 is parallel to the x-axis, so I'm still going to use x values. Now, that means anytime it gives you a line of y equals blah, you're going to use x values still. Here's the thing. If it said x equals 4, then I'm going to switch to y values. So that's something important to keep in mind. Again, in this case, and I'm just going to point this out, the y-axis is, or excuse me, the x-axis is y equals 0. So those two things are parallel, so still use x values. Still use x values. In this case, again, I'm still going to go from 0 to 2. And remember, disk method uses pi times r squared. My radius in this case is x squared, so I just need to square it. So here I go. I'm going to go ahead and start working on this. From 0 to 2 of pi times the radius squared. So x squared squared becomes, again, x to the 4th. That pi can come out front. I'm going to go ahead and just integrate that. We're going to go 1/5 x to the 5th from 0 to 2. Keep the pi. Can't forget the pi. Plug in the 2. Plug in the 0. Just get 0 times 2 to the 5th. We get pi times 32 over 5. So 32 pi over 5. And that's its volume. Okay? Hopefully that helps explain some of the more intricate parts of this. I will make sure I mention there are some harder questions like this, so please feel free. Always ask me your questions if you got any. I'm happy to help you with whatever you need. Just make sure you're paying attention to, again, when you revolve around a special line, if it says y equals a number, make sure you're still using x's. If it says x equals a number, please switch to the y values.